Let's solve LeetCode 1 to sum. So given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. First, let's understand this statement. What do we have to do? Then we'll understand the constraints and the restrictions, and then, well, this is just another constraint. So given an array of integers nums and an integer target, we want to return indices of the two numbers such that they add up to target. So taking a look at the example, let's say we have nums is equal to 2, 7, 11, 15. The target is 9. The output is 0 and 1. That's because nums at 0, which is 2, plus nums at 1, which is 7, is equal to the target, which is 9. So that's what we want to do. We want to find out the elements, the two elements that will match up to the target 9. And we are told that it's only going to be two numbers. We cannot use four numbers, for example, to create the sum. We have only two. So that's one important thing to keep in mind. And yeah, it can be any two numbers. For example, let's say we had another number here, let's say 3 and 6. If 3 and 6 were present, you could use that, or 2 and 7. But here we have a constraint that, hey, you may assume that each input would have exactly one solution. So you won't have 3 and 6 in this array because then we'll have two solutions. Right now, we only have one, which is 2 and 7. Let's take an example 2. So for the array 3 to 4, the target is 6. The output is 1 and 2. That's because 2 plus 4 is equal to 6. So index 1 and index 2 gives 6. For 3, we have target is equal to 6. So we just take 0 and 1. Now, first thing that popped up in my mind was, what if there are elements where, so there's an array where the sum does not match the target at all. You take any combination of two elements, it does not match. And this is solved by, again, this restriction or this assumption. That is, you can have one solution exactly. You won't have two, you won't have 0. You'll always have 1. So that simplifies things for us. And yeah, let's go ahead and find out the solution. So let's say we have 2, 7, 11, 15. The target is 9. I think that's a bit of a weird 9. Let's put a good 9. Yeah. So what can we think of? The very first solution that comes to my mind is go over this once, go over the rest of the elements, and just brute force it. So you have 2, and in the second iteration of the for loop, so you have one for loop, then you have another for loop. The first for loop goes from 2 to 15, the second one goes from 7 to 15, and then you just find out if nums at I plus nums at j equals to the target. But again, we know the problem with this. This is O of n square. We don't want that. We want O of n. And the reason I want O of n, and I can be sure that it's going to be O of n, is because I know if I just go over this array once, I should be able to find out. It just seems so easy, you know, because, I mean, yeah, we only have to go over each element once to figure out if the sum can be made or not. That's why let's find a more innovative solution. So what we can do is, let's say we go over each element and then we can make use of the target as well. So let's say I go over this entire array. I have this target. So I just check 9 minus 2, which is equal to 7. And then I can check, hey, is 7 present in a set that I'm going to create? Now, no element exists in the set initially because we are essentially using the same thing that we saw in the first problem that we solved, which is the contains duplicate problem. The same thing we're going to see over here. So what we are checking is that, hey, subtracting the 2, which is the first element of our for loop, from the target gives us a value that's present in the hash set or not. And initially it does not give us, because 7 is not present in our set. So what we have is nothing. So the condition equals false. So we just add 2 to our hash set. After that, we do the same thing for this 9 minus 7, which is equal to 2. And then we check, is 2 present in our hash set? And that is true. 2 is present in our hash set. And that's when we will return true. But here's the thing, we'll return true. We don't want to return true. We know that we are always going to have one solution. What we want to return is an array of indices. So I want to find out the index of this 7, which I already have access to because I'm looping over this entire array, correct? So I know that I'm at I is equal to 1. That's how I was able to access this element in the first place. But what about 2? In hash set, I did not store what index I'm on. So what I can do is in the hash set itself, when I'm storing the first element, I can say that instead of just storing the number, I'll get creative. I'll store 2, comma, the index of this. So I'll have 2, comma, 0. And let's say, then I check 9 minus 7 is equal to 2. Is 2 present in this hash set? No, we can't know that because we are essentially trying to compare an integer with a tuple here. Because if we are storing it like this, it's either going to be a tuple or a list, and that's not allowed. Or I mean, it will give incorrect answers. So what can we do instead? Well, we can do something like this. Instead of creating a hash set, we'll create a mapping that, hey, 2 is at index 0. So now when we do 9 minus 7 is equal to 2, it will check, hey, is 2 present in this dictionary that we are creating? Yes, 2 is present in this dictionary. So let's get its index. So we have access to 0 now. We also have access to 7, and we'll just return that. And that way our problem is solved. Let's take a more complex example. Let's say we have not this problem, we have the 2-sum problem where we have 3 to 4, for example. And what we are trying to do is get a target of 6. So we go over this entire array. So in the first case, it's 3. So we do 6 minus 3, which is equal to 3. Then in our dictionary that we are going to create, we just check, is 3 present in this dictionary? No. So, well, it's a false situation. So we go to the next element, 2. And also, by the way, we put 3 in this dictionary. So we have 3 at index 0. Then we check for 2. 6 minus 2 is equal to 4. Is 4 present in the dictionary? No. So we just add 2 with index 1. So we just take this 2 and add it here with the index it's on. After that, we do for 4. 6 minus 4 is equal to 2. Is 2 present in the dictionary? Yes, 2 is present. So we'll grab this index, we'll grab this index and return it. So first we'll just return the index of the dictionary because we know it exists prior to this element. Because if it's present in the dictionary, it came before this particular element, right? It doesn't matter what order you put out in because it says you can return the answer in any order, but I would like to kind of match what's here. It's always in ascending, so I'll just do that, but it doesn't matter. The problem states that. So yeah, that's how we're going to do it. So the very first thing we're going to do is go over all of the element in this nums array. But here's the thing, I want the number. I also want the index. So what I'll do is for I comma num in enumerate nums. This will allow me to get the index. So enumerate will help me get the index that this is 0, this is 1, this is 2, and this is an actual number. This is an actual number. So this is I and this is the num. Cool. After that, I need to find out the difference and check if it's present in the dictionary. Where the thing that I did here, 6 minus 2 is equal to 4. So I'll just find out the difference, which is equal to the target minus the num, because I did 6 minus 3, for example, 6 minus 2, for example. So that's what we do. And then we check if the difference is present in the dictionary. Now I have to create the dictionary. So I'll just have, let's say, count, not exactly count. What can we call this? Num to index, because that's the mapping we're doing, number to index. And then we can just do if the difference is present in this num to index. And by the way, here we are checking the keys. So we're just having an O of 1 here. So it's going to be O of 1. It's not going to be O of n. So still our time complexity is O of 1, O of n. And our space complexity is O of n, because we are using a dictionary, which is going to be, well, completed out. So it's going to be n elements long. So yeah, if the diff is a number to index, then we are going to return the diff at, not diff, sorry. We are going to return the number to index at that particular diff. So this will give us the index, right? Because we are creating a mapping here to 0. So if I access the element here, so let's say number to index at 2 will give me the value of 0. So that is the index. And comma can be I, because the second element that we want to do is this particular I, the one I'm looping through. Because the number at index I and the number at this particular index, if both of them are added together, we'll get the value of target. Cool. Now, what if the diff is not a number to index? In that case, we are just going to add it to our dictionary. So we'll have number to index at number is going to be index. That's as simple as it gets. And we don't have to worry about the edge case of this for loop getting over. So, we went through all of the numbers that are present in the list and we did not find any combination. That can never be the case. So we can just run it. And this gets accepted. Now I'll just submit it. And yeah, that gets accepted. The time complexity again is going to be O of n, because I'm looping through all of the elements that are present in the nums array. And the access to the map is just considered O of 1. So we don't need to worry about that. And the space complexity is again going to be O of n, because I'm filling out the entire dictionary. And the dictionary is going to consist of all of the elements until, the target is reached. So in this case, the dictionary only has one element, which is 2, because at 7 we find the correct match. But in this case, for example, we have 2 elements, because 3 and 2 both get filled in the dictionary. So it depends from problem to problem. If you have 1,000 elements, it can contain up to 999 elements, for example. So yeah, it's considered O of n. So yeah, that was the solution.